Hello everyone. Today we are going to see about the image processing. So here are the contents that we are going to see. So in section 1, we are going to see understanding of image processing. Then we are going to see techniques and applications and implementation and collaboration. So first, understanding of image processing. Before understanding of the image processing, we need to understand about the image, a digital image. A digital image is an array or a matrix of square pixels which contain picture elements which are arranged in columns and rows, which we call it as a two-dimensional array. So image processing is a method to perform operations on images in order to enhance them or extract useful information, analyze it, and make decisions. By quantifying the information in images, we can make calculations. Image processing is a subset of computer vision. There will be the pixels in the image. Pixels contain information about the color and intensity. Okay, so we will be having a grayscale image and the color image, which we are going to talk ahead. And applications, there are many more applications. Just I have briefed out. Medical imaging is there. It will be used for disease detection based on the images. Robotics for object recognition. Then we have image restoration. Then we have remote sensing. We can use some part of artificial intelligence in it, and surveillance and many more. Okay, so tools. Today only I'm going to talk about the tool that is scikit image, skimage. Only that one I'm going to talk. This is a library for Python which offers the algorithms for tasks of getting the images and all. Okay, that we are going to see. So image processing techniques. Okay, so image processing techniques, many techniques are there. Just I have shown here 3 with the filtering, edge detection, segmentation. Filtering enhances or suppresses aspects of the image for desired effects. Okay, it can be contrast, sharpness, adjusting of the brightness. And then edge detection, like how we have the object detection, we can detect the boundaries of it, which will help in many of the cases. Even during surgeries also, the things this edge detection can be helpful. Segmentation, this divides the image into segments for a simplified analysis and enabling the extraction of meaningful information. So here you can see RGB and grayscale image. Okay, so what is a RGB image and what is a grayscale image? RGB image is a simple colored image, and grayscale is a sort of gray image. Okay, so here RGB is the two-dimensional color image. Often it will be represented in three layers, 3 colors, that is red, green, and blue. So one layer for each of the color, which will be two-dimensional array. Each one of them will be two-dimensional array. So red two-dimensional array, green two-dimensional array, and then blue two-dimensional array. And we can also call it as red, green, and blue channels of the image. RGB images have 3 color channels. Okay, so in grayscale, now grayscale images are only have the shades of black and white. Okay, so they will be having one channel, which will be of 8-bit integer, giving the range from 0 to 255. So that is 256 possible different shades of color. Gray color. Okay, only gray here it is. We can't say color image. Okay. So grayscale images don't have any color information. It will be only black and white, which we are going to represent. Okay, or shades of black and white. So here RGB has three channels, that is three color channels, while grayscale uh, have single channel, that I said 8-bit integer will be there and 256 possible different shades of the gray will be there. And even we can convert from RGB to grayscale and grayscale to RGB. That is possible using using a function that is RGB to gray and gray to RGB. Okay, it's very simple. So now we are seeing the image enhancement and restoration. Like we have different techniques. Color balance we can do, noise reduction we can do. We can extract the features. Feature extraction will be used everywhere. Okay, so I'll be talking about the scikit image. Scikit image is an image processing library in Python that is easy to use. It makes use of machine learning with built-in functions and can perform complex operations on images with just few by just calling few functions. Okay, we will be using the scikit image today library, and I'll show you how we can get the images. Okay, there are some testing purpose images also. Okay, in that particular library, scikit library. Those we are going to use now to show it how to display those things. Just we need to import the data, and we have to call that particular image with a name. Okay, for that, I'll open the Jupyter notebook. Okay, here we have to open a new Python 3. Okay, so Python 3 it's coming because I'm using third version of the Python. And once this is open, we can start with the coding. Okay, so first line, we need to call data. In data, we have many of the images. So sk image import date. Okay, we can run it by clicking on run. Okay, there are many more options I'll be showing you after like going ahead. Okay, we can take images. I'll take an image data dot. I don't know what all images are there in it. So just I will press the tab. Okay, after dot, I'll press the tab. So here these all images are there, whichever you want you can take. Okay. So cat, I will run it. Okay, we have taken the image, but if I try to print it now, we can print this. If I try to print it, it is printing in terms of array, because as I said, it is a this all will be the array. The images are stored in the array. Okay, all the pixels will be in the array. So to display purpose, we will be using one more library, that is in matplotlib. Okay, and we will have pyplot just to show that particular image. We have different ways to show it. Okay, we can use the tab for it. Sure. Now, if I run this complete one, you can see the image here. So that's it. What we are doing, just we are taking an image, calling it. That's it, and we are getting the answers. Okay, so it's that simple. So now there are. Okay, thank you.